Good day to you all. You are welcome to the lesson today. And in today's class, we'll be talking about another method of solving or finding the integral of a given function. So far, so good. We have talked about the addition rule. We also talked about substitution method. We are moving down to the third method, which is integration by parts. Okay, at the end of today's lesson, you should be able to identify where and how to use integration by parts appropriately. Okay, you recall that in our differentiation, when we find the differentiation of product of two functions, we usually have derivative of the first function, or we keep the first function constant, we differentiate the second one. I mean, keeping the first constant, differentiate the second one, plus keeping the second constant, differentiating the second one, which will give us this. Now what we need to do, we introduce integral sign to both sides. When we integrate both sides, we have integral of this is equal to integral of this plus integral of this. Then what do? We try to make one of these two subject of the formula. Okay, but what I did here was to make, okay, when we integrate this, we have this. Of course, you know, when we have this, we cancel this. The integral of the uv will give us uv. Integral of this will give us this. Integral of this will give us this. From here now, we can make any of these subject of the formula. Okay, but in my own case here, I made integral of u dv dx this subject of the formula. Of course, we know that when we have this one, it will cancel this. We are left with only u, integral of u dv, which is now equal to uv minus integral of v du. And this is what we call integration by parts. So anytime you want to integrate a given function by parts, you must always remember this. Okay, let's have an example on that. Example 1 says, evaluate integral of 2x cos x dx. Integrate 2x cos x dx. What do we do? Okay, at this point now, the first thing that should come to our mind is writing the formula. And what is that formula? The formula says integral of u dv is equal to uv minus integral of v du. At this point now, we should be able to identify which of the function will take u and which one is taking v. Okay, we come back to this. We always make this as our u. Then the one that has the x should be made our dv. Okay, at this point now, we can now say u is equal to 2x. Definitely, when we differentiate u with respect to x, we are getting 2. Of course, then at this point now, we can make our du subject of the formula to have du to be equal to 2 ds, so that we can have it substituted here. The next thing we have to do is move down to our dv. Our dv is already cos x dx. Okay, at this point now we want to integrate dv. Why do we integrate dv? Because we need the value of v, the function v. Okay, let's integrate dv. Therefore, when we integrate dv, that will give us integral of cos x dx. And of course, you agree with me that when we differentiate sin x, we get cos x. Definitely, when we integrate cos x, we are meant to get sin x. So that means v, the integral of dv now will give us v, which is now equal to sin x. Okay, let us now find a way of returning all this back to our normal formula. We have u, which is integral of 2x cos x dx. Now to be equal to, what is our u? We got our u to be 2x, okay? Our u is equal to 2x. V, we got our v to be sin x. So that means dot sin x, okay, minus integral of v. What is our v? Our v, we still have our v to be sin x. Okay, and our du, don't forget the du is equal to 2 ds, which is dot 2 ds. At this point now, we should be able to have 2x multiplied by sin x will give us 2x sin x minus, when we integrate sin x, you of course agree with me that the integral of sin x is negative cos x. Okay, so we should have this giving us negative cos x. Don't forget that this 2 is a constant, cos x, then dot what? 2. So from here now, we can add this to be equal to 2x times x, negative times negative will of course give us positive. Then these two, then okay, we have said that cos what? X. And this will give us the final answer to the integral of 2x cos x dx. 2x sin x plus 2 cos x. But don't always forget to end it up with our constant of integration. And lastly, we have an example showing this one is a little complex. Okay, how then do we have this one done? We still go ahead to have this one to be u, then have this one, the whole of this one, to be our dv. So we can go ahead to have u is equal to s squared. That means when we differentiate u with respect to x, we get 2x. And with this, we can make our du subject of the formula. The u is equal to 2x, the x. You keep that. We move down to the next one, which is the v is equal to s e to 2x, the x. And definitely when we integrate the v, that will give us integral of e to 2x, the x. And which make v to be equal to, when we integrate this, you of course agree with me that what we have is equal to 1 over 2 e to x. Okay, let's find a way of substituting them back into the formula. That will give us integral of x squared e to 2x dx to give us our formula says u. What is our u? Our u is s squared. S squared dot v. What is our v? 1 over 2 e to 2x, then minus integral of v. What is our v? Our v still remain 1 over 2 e to 2x, then dot dv. What is our dv here? Our dv is v du. Okay, our du should be 2x dx. Okay, at this point you agree with me that this will nullify this. Okay, once we have that, we can go ahead to have this to give us s squared e to 2x over 2 minus, this is coming again as a product of two functions. We have 2x as a function, we have half s, half e to x is also a function. So we can still have this one to be 2x dot, okay, we have cancelled 2, let's cancel the 2 properly. Okay. So these two have cancelled this, so we are left with e 2x x dx. And from here now we can have this one to be equal to s squared e to 2x over 2 minus, if we are integrating this, we go ahead again with x. We go ahead with x. So going ahead with x now, we need to apply integration by part again from the beginning to this. And doing that now will give us another, will take us to another level where we have, okay, where we have integral of x e to s. Okay, good, thank you for that. The x, okay, from here now we can say this is our u, then this one with this will be our dv. We can still say u is equal to x, then that means the u is equal to dx. Okay, that is when we have the u over dx, it will give us 1. When we cross multiply, that will give us the u to be equal to dx. Okay, then the next one is our dv is equal to e to 2x dx. So when we integrate now, we have v to be equal to, when we integrate this one, that will still give us 1 over 2 e to 2x. And at this point now, we are meant to now have integral of e 2x x dx to be equal to u, which is our x, dot v, which is our 1 over 2 e 2s, then minus integral of v is 1 over 2s, then dx, du, which is dx. At this point now, you agree with me that this will give us x over 2 e 2x minus, when we integrate this, that will give us 1, when we integrate it, that will give us 1 over 4 e to 2x, and at that point, we are not meant to take the whole of this and return it back here. Of course, at that point now, the final answer will now give us s squared e 2x over 2 minus, now the whole of this is giving us this. Okay, so we can now have minus s squared, s over 2 e to x minus, don't forget that we need to introduce bracket here, 1 over 4 e to 2x. Okay, and at the point here, we open the bracket, and that will give us the final answer. I want to believe at this particular point, you must have learned one or two things. The other material we sent to you in the Google Classroom, where you are going to have as many as possible examples. Have a nice day. Bye.